Using scale factor in dilations. So there's a few examples looking at what you will do when you are using scale factor in dilations. So, first example says we have triangle that has vertices of C, D, and E. Find the coordinates of the vertices of the triangle after a dilation with a scale factor of 2. Remember, scale factor is your K. So here we have the dilation rule. XY is 2x, or 2 times x, and 2y. So notice we're multiplying the scale factor to the x coordinate and the scale factor of 2 to the y coordinate. Your step says multiply each coordinate by 2. You can see right here in the C is -2, -1. Multiplied, that's the scale factor, multiplied by the x coordinate of -2, then the scale factor multiplied by the y coordinate of -1. Once you do that, you get your new coordinates for C prime. And you keep doing the same thing. So for point D of 1, 1, multiply the scale factor times the x coordinate, the scale factor times the y coordinate, and you get your new D prime coordinates. And last one, we have E, 2, -3, multiply the scale factor to the x coordinate, multiply the scale factor with the y coordinate, and you get your new E prime coordinates. So the new coordinates are listed here below, and that would be the first example. Next example, now we have a reduction example. The first one was an enlargement, because remember the scale factor was 2, which was greater than 1, and a greater than 1 scale factor is an enlargement. So here we look at this next example. We have point A and point B. They form a line. Find the coordinates for the new line after the dilation with a scale factor K of 1/3. So because the scale factor is less than 1, that's why it's a reduction. Okay, so here again showing our rule. Take the x, y, and multiply the scale factor to the x, the scale factor to the y. So the steps. Here it says change fraction to a decimal if possible. Well, I wrote if possible because the 1/3, if you changed 1/3 to a decimal, it comes out to be repeating, and you can't multiply with a repeating decimal because then otherwise you'd have to stop writing it. So you're going to leave it as a fraction, plus you guys have the calculator to use, so a fraction should not be a problem for you. So multiply each coordinate by the scale factor of 1/3. So just like before, we took the original coordinates. So the original coordinates of A was 6, -3. You can see multiply the scale factor to the x coordinate, the scale factor to the y coordinate, and it gets you your new A prime coordinates. Original B coordinates, -9, -6. Scale factor times the x coordinate, scale factor times the y coordinate gets you your new B prime coordinates. So we down below have our coordinates for the new line. And hopefully you know, even though you don't see it, because it's a reduction, the line is going to be a shorter line if you actually had to look at a picture. All right, let's look at another example. Now, this time, the example, it is another reduction, but we do not have coordinates. We have a picture with dimensions of 4 inches by 6 inches. There's a scale factor of 50%. What will be the dimensions of the new picture? So you can see here's the original picture. And if it doesn't give you a picture, you can always draw one. So the steps first say to change the percent to a decimal. Now, if you forgot how to change a percent to a decimal, you can either do 50% or 50 divided by 100, or you just move your decimal 2 places to the left, and it gets you 0.5. So then from there, you're going to multiply each side length by the scale factor of 0.5. So you can see here, the 6 inches was multiplied by 0.5, and you get 3. And then the 4 inches was multiplied by the scale factor of 0.5, and you get 2. So now your new dimensions are 2 inches by 3 inches. When you look at the new picture, you can see that the new picture goes smaller than the original. Okay, next example. Similar to the last one that we just did, we have a picture again with the same dimensions, 4 inches by 6 inches, but this time we want to enlarge it. The scale factor of K is going to be 1.5. The scale factor is greater than 1. Now here's my original picture. The steps say to multiply. Again, multiply each side length by the scale factor of 1.5. So you can see right here, I took the original side length of 6, multiplied by the scale factor of 1.5, got 9. Take the 4 inches, multiply with the scale factor, get a new side length of 6. And so your new dimensions are 6 inches by 9 inches. Okay, you see the picture got bigger. Now on the last slide, just things you need to know when you're applying the scale factor. In big letters, you're going to multiply all the side lengths by the scale factor, or you're going to multiply both coordinates by the scale factor. Okay, remember the scale factor is represented by the letter K, and so we are multiplying our original values by the scale factor. And you can see the algebraic rule. The rules for all your transformations are always going to start with the xy, and here we have the K multiplied with the x and the K multiplied by the y. So just remember, when you're given the scale factor in the problem, you need to multiply that scale factor with each of the side lengths that it's asking about or the coordinates that it's asking about. Once you do that, you are done. The other thing to remember, a scale factor greater than 1 is going to give you an enlargement, so your number should get bigger. If the scale factor is less than 1, you're going to have a reduction, so your numbers or your picture is going to become smaller. Good luck.